Components of a transformed vector. In the previous video, we covered the fundamentals of tensor components. In this video, I will be teaching you how to derive the components of a transformed vector. If you are interested in this type of videos, please subscribe my channel to be notified if a video is uploaded. Suppose B equals TA, in which A is a given vector. T is a given tensor which transforms A into B. And B is a vector. We aim to obtain the components of B from the components of A and T. Let's write vector A as A1E1 plus A2E2 plus A3E3. Then we can write vector B as T times the sum of A1E1, A2E2 and A3E3. A1, A2 and A3 are constant scalars and can be taken out. The first component of the vector B can be extracted from the dot product of E1 and B. We substitute B from the above expression by performing the dot product on the bracket and factoring out the constants A1, A2 and A3 we will have. From the equation 275 in the previous video, the dot product of E1, TE1 is equal to T11. The dot product of E1, TE2 is equal to T12, and the dot product of E1, TE3 is equal to T13. So, we can express the components of B using the components of T and A. And in a matrix notation we can write. Notice how to fill out the matrix. Alternatively, we can derive the equation 282 using the indicial notation. Vector A can be written as AIEI. B equals TA. We substitute A in this expression. By factoring out AI, we can write it as AI times TEI. Now using equation 272, we can write it as AI times TJI EJ. Finally, vector B can be written as AI TJI EJ. Bm, the components of the vector B, can be calculated using the dot product of B and EM by substituting B with the above expression. Dot product of EJ and EM is delta JM. Delta JM replaces J with M in TJI. Finally, we will have Bm equals TMI AI. Equation 285 is nothing but the indicial notation of equation 282. Pay attention to the form of the tensor and the matrix notation of this equation. They have the same forms. This is the reason we adopted the convention that TEI equals TJI EJ in equation 272 in the previous video. Because if we had adopted the convention that TEI equals TIJ EJ, then would have obtained B equals T transpose A for the tensorial equation B equals TA, which wouldn't be as natural. Let's see an example. Given that a tensor T transforms the base vectors as follows. How does this tensor transform the following vector? Solution. Using the matrix equation 284, we can write. Notice how to fill out the matrix. The result is a vector with components 2, 5, 8. There is a mistake in this equation. EI should be replaced with EJ. In the next session, I will teach you the sum of tensors and the product of two tensors. Please subscribe my channel.